Welcome back. Today, we're going to be talking a bit more about R, and this time we're going to be talking about how to store lists of things in objects and what you can do with lists. Lists are the most basic form of storing data outside of, storing a single point of data. So you're going to be working with them a lot. Now, a list is a series of objects, say the numbers 1, 2, 3, or 1, 2, 4, 8, and 2, or something like that. That would be a list, but you can't just list the numbers like this. R will get confused. It'll say, what's that? What are those commas? So the way that you create a list or tell R that a set of numbers or words or whatever goes together is you use something called a function. R runs on functions. Functions are essentially sets of instructions that tell R what to do with certain types of information. And the function that we're going to be learning today is C. This is a lowercase c. Case does matter in R. If you use an uppercase C, this won't work. So for functions, you type the name of the function, in this case, just the letter C. Then you do parentheses, and then all the information you're giving the function goes inside these parentheses. So I would put my list 1, 2, 4, 8, and 2 here. And now if I run that, you see, it's like the objects. It'll return the numbers that I gave it to me. And I can save these in an object. So if I copy this, my list, you put an arrow, just paste that there. And now those are stored in my list. And that's how you create a list in R, the most basic way. You can also do this with words. Now the thing is, R will get confused if you just give it plain words. So if I do my word list, you'll want to put words in quotation marks to tell R this is just a word, it's not an object or a function or anything that you need to worry about. So if I said, if I just said like dad, R will get confused because it says object's dad is not found. If you don't have quotations around it, it'll think it's an object like these things up here. So we put quotation marks around it. And we can say mom, sister, brother. And now it'll save that as my word list. And we can call that down here and it'll show me what's inside of it. Pay attention to these commas. If you don't have commas in there, R will get confused. So if I run this without the comma, it's like, okay, I don't know why these two things aren't separated. What is with these two quotation marks right in a row? So the commas just say these are separate items in the list. Now you can index things out of the list. So say I want the second object in my word list. You type the name of the list, and then you put brackets, and I want the second object, so I put a 2 in those brackets. And that should give me the second item in that list. So if I run that, there, it gives me mom, so the second item in that list. If I want, say, the fourth item, my word list, I can also get that, brother. Let's say I want multiple items from that list. In that case, I'm going to give it a list of positions. See, these are positions. So R starts at 1. The thing in the first position is the first thing in the list. The thing in the second position is the second thing in the list, third, fourth, and so on. And that's why 2 gives you mom. Now let's say I want the things in the second and third position. Now there are 2 ways you could do this. If, say, you had a long list and you wanted everything between, say, 2 and 4, you could do 2 through 4, like this. This colon says all 2, 4, and everything in between. And that will give you 2, 3, and 4. Let's say I only want 2 and 4, though. In that case, you will have to give, you can't just say 2, 4. It will get very confused about that. And we'll go into why later down the line when we start talking about data frames. So what you want to do is you want to pass it a list of the numbers or the positions that you want. So you can do that with the C function, like here. And we want numbers 2, 4. So that should give us mom and brother. And there you go, mom and brother. So that's how you use lists, or well, that's the most basic things of lists. That's how you store things in lists, and that's how you get things out of lists. Now let's say I want to do math on my list. So we've got my list, which was a list of numbers. Let's say I want to multiply all those numbers by 2. I can do that by my list times 2. So this is just like when we multiplied, when we added box and yodel or added 5 to yodel or whatever. You can multiply that by 2 and it will multiply all the numbers in the list by 2. So it applies this thing after it to everything in the list. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 2 times 2 is 4, and so on. You can do this with addition, so my list plus 1. You can all, so you can do anything. My list divided by 3, do that too. My list minus 2, it will give you that. And you can save the results of these. So my list plus 2, I can do my list plus 2. And now that will save this as a new list. In general, if you're doing some sort of transformation to a list of things like adding or subtracting or dividing, you'll want to save it as a new object, just in case you need the original version again. Because if I save over this, so if I say I have my list, and then I save over it, like my list, and then I add 2, now the old my list is gone. Now I just have the new version, and I can't get it back unless I go back up here and run the original code again. So in general, if you're going to do something like this and save it as a list, you want to give it a new name, like my list plus 2, just so you don't lose the original version. Now lists allow us to have columns of data. So we could say that my list, actually, maybe my list contains scores on an exam. So this person scored a 1, a 2, a 4, an 8, and a 2. Those are pretty low scores overall. Maybe I didn't do so well teaching this. And now we can apply functions to do this, to get sort of basic statistics. So descriptive statistics, we can start doing things with that. So let's say we want to get the mean. So we want the mean score on this exam. The function to get the mean in R is very simple to remember. It's just all lowercase mean, and then parentheses. And inside those parentheses, you are going to put a list. You just type the name, my list. So it's saying, take the mean of the thing in the parentheses, and the thing in the parentheses is my list. So when we run that, it gives us 3.4. That's the mean of these numbers. You can do this for the standard deviation too. So SD of my list, and that will give us the standard deviation of that list. Sometimes things aren't that straightforward, but generally it is, like median. Also like that. Now sometimes in lists and data, you'll have some missing data. That means maybe somebody turned in their exam late. So if I have my exam scores, and I had scores of 11, 14, 17, and then somebody missed the exam, so I don't have their data. R handles missing data as NAs, so capital N, capital A. So now I have my exam scores, and I have 11, 14, 17, and NA, so the student didn't take the exam. Now if I try and take the mean of that, and scores, it'll give me NA. So if you have an NA in a list and you try and take the mean or the standard deviation, it'll say, hey, there's an NA in here. I can't compute the mean of this because you're missing some information. You can force it to essentially ignore this and pretend only these 3 scores exist by adding another argument. Arguments are like additional pieces of information to a function. So you can say mean exam scores comma, and arguments are separated by commas. So this first argument in the mean function tells you what you're taking the mean of, and then you can go on and add additional information. If you have missing data for mean, the argument you use is na.rm. And as you can see, it's giving me a list of potential things that I can put there. So you do na.rm equals, and by default, the mean function says false. So that says na.rm stands for na remove or remove missing data. And it's by default set to false, so it doesn't remove this missing data, and it spits out na for the mean. Now, if we set NARM to true, that's saying, okay, take this list and give us the mean, but ignore the missing data in the list. Pretend you only have the data points that you actually have. And that will spit out a mean for us. Now, if you ever want to look at a function, say I want to know what possible things I can do with mean, so what it's made for, I want to know, are there any additional arguments like this na.rm? I can do a question mark in the name of the function. So question mark mean, and when I run that, over here in help, it will give us documentation. So it'll tell us where we get it. Mean is in base, that means it comes with R. There are a lot of functions that you might use down the line that you have to download from outside of R. And it will tell you this is a function for getting the mean. Here's how it's normally used. So mean, x is your list. That's the stand-in for the data that you're entering. Trim equals 0. So I believe trim tells you how many decimals, but we can check, yeah. The fraction 0 to 0.5 observations to be trimmed from the end of each x before the mean is computed. So if you have numbers with a whole bunch of decimals, you can trim that. na.rm, this is what we just used. Should you omit or ignore missing data when you're doing it? And then sometimes you can use other functions within functions. And then if you scroll to the bottom, it will give you a reference for how to use it. So here's creating a list, and you can copy this if you want. So this creates a list called x of the numbers 0 through 10 and 50. So if we run x, there's the list it's created. And there's that colon again saying 0 through 10. And we can take the mean of x. So we just take the mean of x, 8.75. And we can also save that in an object. And here we're making another list. So this takes the mean of x, and it'll also give us the mean of x when we trim the numbers beforehand. So there you go. I typically don't use this trim argument. You probably won't have to. These are the most common arguments that you'd use if you're taking the mean. But that's how to use a basic function in R, and that's how you do basic things with lists in R, like creating lists and doing calculations with lists. So that's it for today.